Hello and welcome back for another daily Calculus 1 video. So this is another Calculus 1 video, and today we have an example problem where we are asked the following. Suppose the graph of a function f is given. Write the equations for the graphs that are obtained from the graph of f as follows. A, shift 3 units up. Okay, so if we want to shift a graph by 3 units, let's suppose we have something that looks like y equal to x squared, and we want to shift it up 3 units. Suppose this is 3 units. Then all that we have to do is notice how all that we've done here is literally move this up. Then we can rewrite this as f of x plus 3. And that will literally just shift the whole function up by 3 units. Similarly for down, we can do the same thing. We can play the same trick. So we start here, and we want to shift it down by 1, 2, 3 units, and we get this, and it's literally just shifted down. So that would be f of x minus 3. I'm going to go back so we can see, yeah, here we go. We have plus 3. So this one's going to be f of x minus 3. If we want to shift to the right, however, say we wanted to put this over here, how would we do that? Well, it seems like we would just say something like, well, we can't use f of x plus 3 or f of x minus 3, but it seems like we might do f of x plus 3 as an example. But notice that if we were to do that, that actually it would shift us to the left. And the reason is because if I go 1, 2, 3 over, that's where I end up. So this actually, if I want to shift 3 units to the right, I have to do f of x minus 3. And you should go back and verify for yourself if you were to substitute in a number, say, because we want to start at f of x equal to 0. That's an easy part to, if we're just shifting to the left or the right. F of 0 here should be 0. And in this case, to get to 0, I actually have to have negative 3 for x. Because negative 3 plus 3 is equal to 0, in which case would give me my 0 back. And just go back and verify for yourself that this works. Now, if I want to shift for the same reason, if I wanted to shift to the left by 3 units, then I have to have f of x plus 3. How about reflecting across one of the axes here? So let's just erase this for a moment and we'll come back to it. We have this, and then we have our nice little function here. And we want to reflect this, so we wanted to think of this as going in a mirror, and we want it to come down here. And this is what it should look like if it was reflected. This should be the reflection in the x-axis. Okay, and so how would we do that? Well, you can verify to yourself that if I multiplied by the negative of this, it would end up being down here, and similarly the negative of this would end up down here. So to reflect in the x-axis, we should have negative f of x. I'm going to go back again so that we can see all of our problems. The next one, I believe, is going to ask us, as I recall, to reflect about the y-axis. Okay, so for the reflection about the x-axis, we found that it was negative f of x. To reflect about the y-axis, well, it's kind of hard to see with this particular function that we've been using, the x squared function, because it's already symmetric about the y-axis. So if I reflect it, it's just folded over on itself and it looks the same. So maybe we should use a different function. Let's say maybe x cubed. So to reflect about the y-axis, then this should come out the same distance across this way, and similarly up here should come out the same distance, and so on. And so we end up getting something that looks like this. That's the reflected version. And so to get these to match up, I need f of negative x. Because notice that if I take this and then I reflect it over here, it's the same distance along the x, but away from 0, x equal to 0 as it was before, but now it's on the negative side, so that's why we need f of negative x. And you should definitely play around with using some values here to verify that what I'm saying is true. The next one was we want to stretch vertically. So we want to take this and we kind of want to make it get stretched out in the vertical direction, like so, by a factor of 3. Well, that's just going to be, if we stretch vertically by a factor of 3, it's just going to be 3 times f of x. Okay? And then the last one was if we wanted to shrink it vertically, so in this case it would look something more like this. And that would just be 1/3 f of x. So this is how we do these kinds of shrinking and stretching and shifting. So these are just taking old functions and turning them into something new. That's usually the name of a chapter that includes these kinds of transformations that we've been doing. That's all that I have for this video. I hope to see you again next time.